Yes, and now, so this topic is communication, or what is sometimes referred to as cheap talk. Uh, Now, if you think about it, in many economic or political or social interactions, communication is very important, right? Language and communication. Um, so here are some randomly chosen examples. In international conflict, nations often make verbal threats and promises that we will not tolerate a nuclear Iran, right? American presidents and leaders making statements like that. Now, the Iranian leaders and other global leaders and citizens wonder, do they mean it? If Iran keeps on uh, with their nuclear program, will America strike? Or are they just making noises that they will not launch a military strike? We wonder about the credibility of the statement. Politicians make campaign promises all the time, before the election. These are verbal promises. They're not legally binding contracts. Yeah. And often voters wonder, do they really mean it? Will they break their promise if once they come into office? A very famous instance of this was in the 1992 American presidential election. So the sitting president was the senior President Bush, George H.W. Bush, and his challenger was Bill Clinton. And on a TV debate, Bush was saying that, I'm in favor of small government. Uh, I'm not in favor of raising taxes, even though there was a recession going on at the time. And deficits had become very large. So the TV, sorry, this in the 1988 election, Bush made that comment, and the interviewer put him in the spot and said, "Can you look at the TV camera at the voters and say that he won't raise taxes?" And Bush said on TV, "Read my lips, no new taxes." But then, deficits grew very large, and over the next 4 years, there were tax increases. And then in the 92 election, Bill Clinton played that tape over and over again, that you cannot trust President Bush because he says one thing to you before the election and then does something else. Policymakers are often, when there are rumors or concerns about the economy, is there a recession coming? Is inflation sort of rising? And then policymakers like, the governor of the Reserve Bank or the finance minister, they will issue statements trying to reassure citizens. Before the 2008 financial crisis, famously, Alan Greenspan, the chairman of the Fed, said fundamentals of the economy are strong. And shortly afterwards, there was this major, major crisis. So once again, to what extent will economic actors take these statements in a credible way? Famously, the credit rating agencies, these days, we are talking about all these Moody's and Standard and Poor's, these credit rating agencies, they have gotten it spectacularly wrong, right? So these credit default swaps, these financial instruments were ranked, given sort of highest AAA ratings up to a few days before, the whole thing imploded. And so that badly damaged their reputation. Companies make various claims in their advertisements and so on. So I can go on with examples. Now, all these examples differ from other kinds of messages that you have found in your study of microeconomics, right? One kind of messages is signaling theory. Yes. If you take the Spence signaling model, the workers are choosing, before applying for their jobs, they are choosing certain levels of education, low or high. And so the choice of education level, you can think of that as a message. Yes. The thing there is that the message is costly. It has a direct cost. If you want to acquire a master's degree, you have to pay the fees, you have to sacrifice income for a couple of years, and so on. So it comes with a cost. And the differential cost is at the heart of the signaling theory. But the important point is that there's a cost. If you think of all these verbal statements in these examples, they're costless. They may have an indirect cost through their implications, through how they affect the beliefs of others and their actions. So it may have a feedback. But there is no direct cost to making these statements. That's why they're called cheap talk. And that's what sets them apart from signaling theory, where the messages, quote unquote, are costly messages. They do have a direct cost. Another context in which, in theory, you come across messages and so on is in mechanism design theory, right? So the way the problem is formulated is that there's an asymmetric information problem somewhere. A lender is thinking of giving a loan to a borrower, but the lender doesn't know various aspects of the borrower, how much of a default risk there is, for example. And the lender is trying to tease out their information. Or in the used car market, whether the car being put on sale is a lemon or a peach, high quality or low quality, that is asymmetric information. And in mechanism design theory, the designer tries to extract this private information. And the way it's set up is that, the party who has the private information, like the seller of the used car, is supposed to send a message, make an announcement that my car is high quality or low quality. And the mechanism specifies what will happen after such a message. Now, in mechanism design theory, the mechanism specifies after a message what actions will happen, what allocations will be done, and what payments will take place. So there's a commitment to what is to be done after the message is transmitted. In cheap talk theory, that commitment is not there. After the message is announced, every other player who hears the message is free to do whatever he or she wants to do. I'll talk more about that and talk more about the difference between mechanism design or contract theory and cheap talk theory that we are going to study. But there's an absolutely critical, important difference, which I'll just mention at this point and elaborate on later, which is the assumption of commitment. In cheap talk theory, there is no commitment on anybody's part of what will be done, what actions will be taken after the message is heard. And that's what sets it apart. Anyway, so cheap talk. Does cheap talk matter, right? Messages, if it doesn't cost me anything to submit a claim, make a speech, make an announcement, can I really have an impact on the decisions of others through making such cheap talk pronouncements? That's the question. And if these quotations are bringing out sort of a gamut of opinion on that question. Steven Pinker is a psychologist, is a brain scientist of some sort. He has a number of very interesting books. His first book is called The Language Instinct, which is a very nice layperson's introduction to Chomsky's theory of language. Anyway, so Steven Pinker here is saying, he's marveling at this feature that our species has, which is that, we move our mouth and our tongues and we can convey such complex thoughts and ideas into the brains of others. If you think about it, it's quite spectacular, actually. I mean, we are so used to it that we don't marvel at it. But compared to other species have, They have some vocal sounds, vocalizations, but they're just a few broad emotions. They can't convey complex thoughts, new thoughts, an infinite number of permutations of these sounds, which convey potentially very, very rich information into the minds of others. Anyway, so Pinker's quotation here takes us to the optimistic end of the spectrum, saying that when economic actors can make these sounds that we call language with their mouths, there's a huge potential for sharing information there. Yeah, that's excellent. But then comes the problem of credibility, right? Yes, I go to the store, the salesperson at the store says this is the best TV ever made. A company puts out a job ad or comes for a campus interview looking for candidates, and each candidate says, I am the smartest, brightest, most hardworking worker that you can ever hire. Who'll claim otherwise? Yes. So the problem with, there are two kind of problems with language that language has to solve. One is meaning, right? You go to a country whose language you don't speak, the primary problem there is understanding the meaning of what is being said. But even when we have a shared language, the other person is speaking English or Hindi or our mother tongue, there's a second problem we may run into, which is credibility. Should we believe them? To what extent should we believe their claims? And so the other end of the spectrum is something like this. Yogi Berra's witty comment that an oral contract is not worth the paper it is written on. Okay, so the classic paper which models cheap talk is the Crawford Sobel paper, Econometrica 1982. So that's what I'm going to talk about today. There's a god-awful sound. Can you guys hear some background noise or sound?
It isn't troubling us though.
Huh?
We can hear you.
I don't know where it's coming from, but there's a continuous terrible sound which is going on. Anyway, okay, so the Crawford-Sobel model, yeah. This paper was very famous. It was written in 1982. And then for 15, 20 years, there was hardly much follow-up literature on this paper. And then some 2 decades later, there was an explosion of work which was based on Crawford and Sobel's original paper. So it has a bit of a strange intellectual history. Now, if you look at the paper, you'll find that the model there is very general. They've tried to sort of make it as general as possible. I will not talk about the most general model. I will talk about what is called the uniform quadratic version. So some functional forms will be assumed. Many or most of the results that I'm going to talk about will generalize to a much more general structure, right? So it doesn't have to depend on this uniform distribution, etc. But the uniform quadratic version is algebraically very friendly. It's easy to solve, right? So we'll use that to get our insights. Keep in mind that the things, the effects we are talking about are more general. Okay, so there's a sender and a receiver. Okay, so let me tell you a story to go with that, so that you can always relate the abstraction to something concrete. Oh, the noise has died down, thankfully. So imagine that there's a top decision maker, a prime minister or a president, right? And the prime minister has to decide on the defense budget, let's say. Yes, how much money to allocate to defense. Now, that partly depends on what the threat perception is. What are the intelligence agencies and their reports telling us about our external threats or the degree of the external threats that we face? Um, Now, that is a technical issue, right? Only experts spending a lot of time can come up with an assessment about the external threats. So the prime minister has a defense minister or a national security advisor, some expert who doesn't take the final call, but who can read through all the intelligence reports, assess them, and understand what the degree of threat is. And the prime minister doesn't have the time because the prime minister has to attend to so many different things, right? Defense, economy, et cetera, et cetera. So the prime minister has to rely on the expert. Now, both the prime minister and the expert, of course, would like to increase defense expenditure when they sense that the threat has gone up. And then they would both want to allocate more money into the defense budget. But if you fix a certain threat level, right, then the prime minister and the national security advisor may differ about how big the defense budget ought to be. For example, if the national security advisor is a hawk, right, then the NSA would like, for a given threat level, the NSA would like a bigger defense budget than the prime minister. Okay, so take these two features as given, that for a given threat level, the NSA wants a bigger budget, and for higher threat levels, both of them want the defense budget to expand. So then an interesting game ensues, right? Since the NSA has the time and the expertise to assess the level of threat, the NSA will want to exaggerate the threat, right? Whatever the threat level, the NSA wants to paint a more stark picture to the prime minister in their sessions, in his advice, so that the prime minister is misled into allocating more funds into the defense budget. Now, the prime minister knows this, that there is an incentive to exaggerate. So whatever the NSA tells about the external threat, which is currently there, the prime minister will discount that. Yes. And now this happens in waves. So the national security advisor knows that whatever picture he paints, the prime minister will tone it down, will say, okay, he's exaggerating 20%. And so he exaggerates even more. And so you get caught in this spiral of exaggeration and discounting, of hyperbole, if you will, and skepticism, right? Same thing happens when professors are writing recommendation letters, right? So I'm writing recommendation letters. I have some reason to give good, truthful assessment of the students' achievements and capabilities, but I have some degree of favor for my students or students from my institution compared to, let's say, ISI. Yes. So I have a reason to exaggerate a little bit in the recommendation letters I'm writing for, let's say, the PhD applicants. Now, the graduate schools who are reading these recommendation letters know that. So they'll discount what I say a little bit, right? So if the student is good, I have a reason to say excellent. And so the graduate admissions committee, when they read excellent, they'll say, oh, he really means good. He's exaggerating. So once I figure that out, instead of saying excellent, I would say genius, so that they tone it down to excellent in their minds. But then it keeps escalating, or it potentially keeps escalating, where perhaps in all my recommendation letters, I'll write that this student is the next Kenneth Arrow or something, right? So where does this end? Can we tie it all up through game theoretic analysis and applying notions of equilibrium? Okay, back to the model. Keep the example in mind. I'll keep referring to it over and over. So in more abstract terms, there are these two players, sender and receiver. So sender is like the advisor and receiver is like the prime minister, the decision maker. The state of the world is captured by some random variable theta. We'll assume it's drawn from the uniform distribution on 0, 1. So theta is like the degree of external threat. Higher theta, theta means there's a stronger threat coming from other countries. And there's an action to be chosen from the 0, 1 interval. The action is A. So think of the action A as the size of the defense budget. Yeah. And the information structure is very critical. The sender knows the exact value of theta. The receiver only knows that theta is drawn from this distribution. So the distribution of theta is common knowledge between sender and receiver. But the realization of theta is only known to the sender and not to the receiver. So the receiver can only learn it from the sender and not have access to that information directly. So information is very one-sided. Information rests with the sender. On the other hand, the receiver has complete power in choosing the action. Right? Sender cannot directly provide any kind of influence on that, except through cheap talk. So decision-making authority rests with the receiver. So this is the simplest, starkest possible model of communication, right? Information and decision-making authority are totally divorced. One party has information, the other party has the authority to choose the action, and they are vested in different parties. And there's no third party, fourth party involved. As we go along, you will see that, I'll talk about a few games, some variations where you can bring in a third party. You can extend all of this, but this is a useful starting point to understand some of the basic principles. Okay, so now we have to talk about preferences. What are preferences like? So these are the utility function of the receiver and the sender. And we'll assume they're of this quadratic form, okay? So if you assume for a moment that it's a world of full information, both sender and receiver knows the exact value of theta, then the receiver will want to choose an action which is equal to theta. Notice that this is a square thing with a minus, right? So the lowest value that it can take is 0. And it takes that value when A is equal to theta, right? So the optimal thing for the receiver is to match the action with the state. For the sender, you have a similar thing, except that this extra term B is a parameter. It's a preference parameter. It's fixed, right? It's exogenous. So if you look at the sender's payoff, if the sender could choose the action, of course he can't in our game, but if he could, then he would want to choose an action which is theta plus B. Again, that reduces this negative quadratic term to its lowest value, 0. So their bliss points, so to speak, are different. Both their bliss points are sensitive to the value of theta, to the state of the world. When the state of the world is more to the right, they would also like to choose actions more to the right, but not to the same degree. And B, as you can see, we will call it bias, the sender's or the advisor's bias factor, right? If B were 0, then their objectives, their motives would be exactly aligned, and there really wouldn't be any interesting problem. But the interesting case is where B is non-zero, and in general, without loss of generality, we'll take B to be a strictly positive number, right? So the higher is B, the greater is the divergence between the interest of the speaker and the listener, the sender and the receiver, right? And in this simple game, this is the move sequence. The sender learns theta, gets to see the exact realization of the state of the world. Then the sender sends some message to the receiver. And after that, the receiver chooses the action, and the game ends and the payoffs are realized, okay? What does a message mean? For simplicity, you can think of the message being some real number. It doesn't have to be, it could be words, it could be something else. Okay, it could be a color that he displays on a placard, or it could be anything. It's a very general thing. But to fix ideas, you can think of the message as a real number. Okay, let me explain the nature of the structure of preferences here in terms of pictures. Okay, now I had some trouble bringing in Greek letters here. So this question mark is actually theta. So wherever you see a question mark in the next few slides, think of that as theta. Okay. So if let's choose a particular value of theta, let's say 0.4. Okay. The moment you fix the value of theta, I can draw a utility curve for the receiver, right? And it peaks at, the utility peaks at exactly theta. I made the mistake of drawing the origin at the wrong point. The origin should really be 0, right? So it's this entire curve should be in the negative quadrant. But in any case, this is, his payoff peaks at theta. Now, what about the other player, the sender? The sender's payoff, which is the red graph, peaks at theta plus b. So if theta was common in a world of full information, the prime minister and the national security advisor are both have a precise estimate of theta. They both know theta. In that case, choosing an action below theta would be bad for both of them. It would be Pareto inefficient. Choosing an action higher than theta plus b would also be Pareto inefficient. Both parties would be better off if the action was reduced. And this range is really the conflict range. The range of action choices between theta and theta plus b. That's why there are opposing pulls. So if the action is here, the prime minister wants to lower it, and the national security advisor wants to increase it, right? So this is the interesting zone, the zone where their interests move in opposite directions. So one thing you can see right away is that there's common interest between the two parties as well as some degree of conflict. This is the zone of conflict, and all the other ranges beyond that are zones of common interest. Now, this picture is drawn for a given value of theta, okay? What if theta goes up? So the external threat becomes stronger, more serious. Then these utility graphs will move, obviously, and they'll move to the right, and both of them will move to the right. So if theta increases to theta prime, the prime minister's bliss point moves up to here, and the advisor's bliss point moves from theta plus b to theta prime plus b. Yes. So that's what the speaker may want to try and manipulate. The fact that by reporting a higher theta, if that is believed, he can manipulate the decision maker into choosing a higher action. That is what will complicate matters and muddy the waters. Questions? Everybody, is the model clear to everyone? Any questions? Okay, let me move on. So,
what was the interpretation for the A that the receiver chooses?
Interpretation for the A.
Yes, sir.
A is in abstract terms an action. In terms of the example, A is like the defense budget. How much money allocated to defense? So theta is like the strength of the external risk, and A is the size of the defense budget.
Right, so it's like a predisposition that a person has towards, say, the budget.
No, A is a choice. A is a choice. B is the predisposition, right? B tells you that for a given level of threat, what is the gap between what the Prime Minister would want to choose and what the National Security Advisor will want to choose as the size of the defense budget? So B captures the difference in their predispositions towards the problem, right? But A is just a choice. A is not a predisposition. Right? The optimal value of A will, of course, depend on their predispositions, but A itself is just, the size of the defense budget, which is a matter of choice. Okay.
Sir, the message being sent by the sender,
Yeah.
it belongs to the uniform distribution of 0 to 1, right?
We
Like
can restrict it there. Okay, let's, we don't have to, but we can restrict it to that range, yeah.
Okay, so thank
you. All right. So let's define what a perfect Bayesian equilibrium means in this game, right? And this is just definition and notation, right? Nothing interesting in this slide beyond that. So you can think of the sender strategy as a function m of theta. For every theta, what is the message that the sender will send, right? If theta is 0.4, will the sender say that it's 0.5 or 0.3 and so on? Yeah. So it's the mapping from information or the true value of the state of the world and in some sense the reported value of the state of the world. Now, after every message, the receiver will update his beliefs, right? He will have, initially his belief was that theta is uniformly distributed on 0, 1. After hearing a particular message, he'll have a new probability distribution, and that is what G of theta given n is. It's a conditional probability distribution, conditional on the message. And finally, there's a receiver's strategy, which is a mapping from messages to actions. For every message, what is the action he's going to choose? Right? That describes the receiver's strategy. Now, for these three things, for these two kind of actions and this kind of conditional probability distribution to make up a perfect Bayesian equilibrium, it has to satisfy a number of conditions, right? The first condition is that the sender must be playing a best response, okay? So given the true state of the world, the sender is supposed to send the message m of theta, okay? What if he, instead of the equilibrium message, he sends some other message, right? He should not be able to increase his payoff by deviating to a non-equilibrium message. That is one condition. Let me skip to the last, and I'll come back to the second last. Receivers must also be playing best responses. After hearing the message, they update their beliefs. After updating their beliefs, the receiver must choose an action which maximizes her expected utility. And that's what this last line says. Finally, the beliefs have to be rational whenever possible, right? So if a message is supposed to arise in equilibrium, then the receiver must be coming up with the new probability distribution using Bayes' rule, okay? So let me not dig into the details of this, but these are the standard conditions of a perfect Bayesian equilibrium. Things will become very clear when I walk through the equilibrium. So what kind of equilibria can we find in this game? There's one equilibrium which is very simple, which will always exist. It's called the babbling equilibrium, right? What is this equilibrium? In this equilibrium, the sender's message is independent of theta. It's some sort of constant message. For example, just as one example, suppose the sender always says half. No matter what actual theta is, whether it's 0.1 or 0.8, the sender always claims half, let's say. I could put down some other number, but the sender makes a constant claim across all states of the world. If that is the case, if that is indeed the sender's strategy, then the beliefs of the receiver will not be adjusted, right? After every message, the receiver will continue to believe that theta is in the interval 0 to 1 because the message is totally uninformative. Yeah. And then the receiver strategy is to choose an action which maximizes his payoff. Now, in this uniform quadratic kind of example, let me not go all the way back. I will leave it to you as an exercise to prove, and it's very, very simple. The optimal choice of action for the receiver's part is to choose the expected value of theta. So let me put that down as a claim. Right? If you know theta for sure, you choose an action which is equal to theta as the receiver. If you don't know theta and you only know there's a probability distribution over theta, you calculate the expected value of theta, and that is your optimum action choice. Okay. So let me take that as given, and you can try and prove it yourself. And it's just a two-liner. So if the receiver continues to think that theta is uniformly distributed on 0, 1, the expected value is half, and that's going to be the action choice, right? So all the pieces fit, all the conditions are satisfied. If the beliefs are immobile, right, no matter what message is sent, the receiver does not change his beliefs, then the sender is indifferent between all the messages and might send half, might send 1/3, it doesn't matter. The receiver's belief will be immovable, and the receiver's action choice is always going to be half. Essentially, the babbling equilibrium is an equilibrium where whatever is being said is thought to be meaningless and uninformative. Yes. And therefore, it doesn't affect the action of the decision maker. And because it doesn't, the speaker has no incentive to speak carefully. The speaker says whatever, right? If I don't think people will believe what I'm saying or take my advice, I might just as well, hum a tune or recite a poem or something. I don't feel any reason to speak the truth or anything else. So the babbling equilibrium is a self-fulfilling prophecy, right? If the speeches are supposed to be uninformative, all sides have an incentive so that that indeed turns out to be the case. Everyone with me? Everyone see why this is an equilibrium? Now, this is not a very interesting equilibrium. However, it always exists. And you will note that even if B were 0, that is to say that two have the identical preferences, even then you will have a babbling equilibrium sitting there, right? Okay, let's move beyond that and let's think about whether something a little better can be constructed. Is there another equilibrium where some amount of information is transmitted? And the answer is yes, although we need some condition on that. But under certain conditions, yes, we can construct a non-babbling equilibrium. So let's try something of the following type. We'll try to construct a partition equilibrium. Yes. And we'll try to create a partition equilibrium with two intervals. That is to say, for a range of values of theta from the lower end, 0 up to some threshold, the speaker, the sender, will send one message. And for another range of values from that threshold all the way up to 1, he will send a different message. So M1 for the lower values of theta, M2 for the higher values of theta. Can we construct an equilibrium of this sort, where all the range of possibilities is broken down into two categories, high and low, if you will, and the sender just announces whether theta falls in the high interval or the low interval? And the answer is yes, under some conditions we can do that. And the threshold will have to take a specific value for this to work, and that we can calculate what that value has to be. So that's what I'm going to do there now. So let's say the threshold is theta t. Theta t here is not time, right? It's just what? Threshold. It's some. So in the equilibrium we're trying to construct, the message strategy is like a step function. So for this lower range of thetas, the message sent out is M1. For the higher range, it's M2. Okay. Now, what will the receiver's beliefs have to be if this is to work as an equilibrium? Well, the receiver's beliefs has to reflect this message strategy. And so basically, when he hears the message M1, his belief now becomes a uniform distribution on the 0 to theta t interval. Instead of 0 to 1, it collapses to a uniform distribution over the smaller, lower interval. And when he hears the message M2, this should, or any other message, okay, even off the equilibrium path messages like M3, M4, which were not supposed to be altered. For any other message, we'll assume that the updated belief is uniform distribution from theta t to 1, threshold all the way up to 1. Okay. These beliefs are rational beliefs as perfect Bayesian equilibrium requires. Finally, the receiver's strategy has to be optimal given his beliefs. Okay. So when he hears the message M1 and he thinks that theta lies in that lower interval, he wants to choose an action which is the conditional expectation of theta in that lower interval, right? And as you know, in uniform distribution, the expectation is always the midpoint, right? So, so when the message is M1 and the interval is the lower interval, the optimal action choice is theta t by 2, average of 0 and theta t. And when it's the other message, it's the midpoint of the higher interval, which is 1 plus theta t divided by 2. Okay. Now, we have, so far, what we have done is we have guaranteed that receiver's beliefs are optimum. We've also guaranteed that the receiver's strategy is a best response. The last thing that we have to guarantee is that the sender's strategy is optimal for the sender, right? And that is captured here. So essentially, what it boils down to is the sender knows that in equilibrium, he can induce this action by sending the message M1, and he can induce this action by sending the message M2, or any other message for that matter. So the sender will essentially ask himself, after he sees the value of theta, he'll ask himself, do I want this action or do I want that action? So his choice boils down to a choice between these two actions, right? And that's what this is saying, whichever is closer. So in the lower interval, he must prefer this action. In the upper interval, he must prefer this action. So in the lower interval, he must prefer the midpoint of that interval for every value of theta in that interval. And for the upper interval, you know, the corresponding. Let me explain it further with the picture, right? So suppose this is our threshold of the equilibrium we're trying to construct. This is the dividing line. So the message will be M1 for all theta in this range, and the message will be M2 for all theta in this upper range. And the theta t is the dividing line between them. So the actions, if for message M1, the action will be half of theta t, midpoint here. For the message M2, it'll be the midpoint of the upper interval, half of 1 plus theta t. Now, if for all of these thetas, the sender is to like this action, and for all of these thetas, he's supposed to like this action better, then what should be true at the threshold? If he sees that theta is exactly equal to theta t, which action should he like better? Anyone?
Indifferent.
Should be indifferent, right? So all these threshold type equilibria have this property. At the threshold, there is indifference. So at the threshold, he has to be indifferent. What does that mean? At the threshold, what is his ideal action, his bliss point, right? If he could choose himself, what would he choose?
theta plus b.
Theta t plus b, right? So this is his bliss point. That's where his utility or payoff peaks. Now, of course, he doesn't have the luxury of that because he's not choosing himself. So he can only influence the choice through his messages. And through his messages, he can only induce either this action or that action. So now, if he has to be indifferent, that means these 2 points have to be equidistant from his bliss point, right? Given the quadratic preference that we have assumed. So that means that at these 2 points, his utility should be the same, which basically means that this distance, the gap between the lower action and his bliss point, should be the same as the gap between the higher action and his bliss point. Okay. Now, if we write that down in algebraic terms, we get this. Yes. So this is very easy, right? The theta t plus b minus this half of theta t should be equal to half of 1 plus theta t minus theta t plus b. So you write that down. It's a simple linear equation, and that helps you solve for the value of theta t, which turns out to be half minus 2b. Okay, so the threshold will take b to be positive, right? So the sender, without loss of generality, if b were negative, everything we say would be a mirror image. So the sender has an upper bias or a right bias. If that is the case, then the threshold will be left skewed. The left interval will be smaller, the right interval will be bigger. Right? Now, there's one condition which is needed, which is that this threshold shouldn't, that what we have calculated using the indifference condition, it should be a genuine point in the 0 to 1 range. In particular, it shouldn't be negative. It shouldn't go below 0 because then that's nonsensical, right? So that won't be an equilibrium. So we need half minus 2b to be non-negative, which means we need b to be less than or equal to 1/4. So this sort of equilibrium exists provided the bias is not too big. What do we mean by not too big? Well, 1/4 is the precise value. Okay. So the takeaway points, we do need some upper bound on the bias to construct a non-Bambling equilibrium like this. And this is the simplest, the crudest non-Bambling equilibrium we can construct, right? Just 2 categories of information. But that requires some limit on the bias. If the bias is too big, we won't be able to construct even this. That's one point. The other point is that if the bias is towards the right, then the equilibrium interval gets skewed to the left, right? The left interval is small and the right interval is big. Yes. So if you think of theta being the merit, the academic merit of a student, and the professor is reporting that in a recommendation letter. One possibility is that the professor will create 2 grades, if you will, right? A students and B students. But the A category will be very crowded and the B category will be smaller. And when a student is labeled as B, that will be very informative because the range of possibilities there is much smaller. Right? The left interval is narrow. But A will not mean too much. A whole lot of students will be lumped into it. You hear about grade inflation, right? In America, there's a lot of talk in academic circles about grade inflation, that they have these letter grades, A, B, C, D, F. And many people complain that 90% of the students are getting A's. So the grade of A has almost become meaningless. Grades of B and C are meaningful, but in a negative way, that it's not meant to be very good. But A is like a very faint praise, if you will. So here you can see some of the sort of strategic reasons why you may expect grade inflation like that. Yeah. Questions? No questions? Okay, let me quickly talk about a point here. So let's say the receiver, so if this is the equilibrium, this partition equilibrium with two intervals, so the information actually is very fine-grained, the true raw information, right? Theta is a continuum drawn from a continuum. But the information that reaches the receiver, the prime minister, comes in just two categories, right? High and low. Now, we can ask an operations research kind of question, which is that if it has to be two categories, right? Suppose a machine is going to spit out the information, and the machine its output has to be binary because the machine has only has one light, and either the light will go off or it will remain off. That's the only way the machine can convey the information which it has processed. But we can program the machine that for what range of thetas should the light go on, and for what range should it remain off, right? In other words, suppose the receiver could choose the threshold, yeah, to cut up the information. Where would he want to place the threshold? In the equilibrium of this game, the threshold is placed, of course, at half minus 2b. But if somehow, hypothetically, as a thought experiment, the receiver could choose where the threshold is placed, where would he want it placed? Now, by what criterion? Let's say the receiver's ex-ante expected payoff. Okay, so here's that expression. Choose an arbitrary x, then the receiver's so whenever theta falls in the 0x interval, the receiver learns that, chooses the action x by 2. Whenever it falls in the other interval, he learns that and chooses 1 plus x divided by 2. And so these are the two errors, if you will, in that utility function, right? And the two errors, sorry, there should be an integral here, little typos. So integral x to 1 before this second term, right? So, so that's the expected payoff. And now you can take the derivative of this expression, set it equal to 0, and find the optimal value of x. And when you do that, you'll find it to be half. Okay, so you do that math yourself. Let me give you the intuition why. Why, if it has to be two intervals, it's best if the intervals are kind of equal length. Now, why is that? See, when there's a small left interval and a large right interval, when theta falls in that small left interval, it's very useful. You get to learn, so you can choose an action which won't be too far from the full information action, the ideal action. But if theta falls in the right interval, which is huge, then knowing that is not very useful because you choose the midpoint of the interval and the actual theta can be pretty far away, right? So you're not able to customize your action too closely to the state of the world. Now, if the left interval is small, yes, if theta falls there, it's useful for you, but only rarely will theta actually come from that small left interval. Most of the time, it'll come from that large right interval, and that information has very little value. Okay. So that's the rough intuition why ideally it should have been equal sized. Now, let's step back and let's identify what we have learned here. What are the insights in this, looking at this example?
So can you please repeat the intuition?
The intuition is So this is the range of possible values of theta, uniform distribution, right? And we can choose a point as a cutoff point so that the information will be broken down as, whether it's coming from the left of the cutoff or from the right of the cutoff. And so suppose we choose the cutoff here, extremely to the left, extremely moved in one direction. So then either we learn that theta belongs to this small little interval on the left, or we learn that it's coming from this large right interval. Okay. Now, if we learn that it's coming from this small left interval, then will be that will be very informative and very useful in decision making, because it's a very small range of possibilities. So even if I choose the midpoint, yes, I may not be able to hit the exact value of theta, but I'll be very, very close. Yes. So in this case, the error will be close to zero. Okay. So great if it comes from here, right? Triple great. If theta, however, ends up being in this range, then the error on average will be very high, because it's a whole range of possibilities. I'll choose the midpoint, and often I'll be far from the actual value of theta. Okay, so this is a lot of value, and this is kind of sort of not very useful. An extreme version of this is when the cutoff point essentially converges to zero. Think about that. In that case, essentially you've learned nothing, right? Almost always theta will come from the right interval, and the right interval is practically the 0-1 interval. So you can see in this limiting case that the information coming from this binary structure is practically useless. Yes. Now, on the other hand, if the cutoff is in the middle, exactly in the middle, then that's much better than these, because you either learn that it falls on the left or on the right. And in both cases, there's a modest amount of usefulness to learning that, because then you can choose the midpoint here or the midpoint there, and you can do some amount of customization of the action to the state of the world. Yeah, of course, this is not a proof. What the proof is solving that, that maximization exercise. This is rough intuition. Okay, so what do we learn here? Observations. Cheap talk can be useful. It can, through purely costless cheap talk messages, some amount of information can be conveyed. That's what's happening in this binary interval. So all hope is not lost, okay? Even if this is not costly signaling, the information potential is there, right? But at least in this interval that this partitional equilibrium we have just looked at, the information is coarse, right? So the true state of the world is a continuous variable, but I only learn about some broad intervals in which theta lies. Yes. So the information is coarsened because of the strategic reasons and the credibility problems between the sender and the receiver. So we learn something from the conversation, but not everything, at least in this equilibrium, right? We'll look further. For a two-message equilibrium, for this some amount of information to be transmitted, the sender's bias can't be too large, right? So if there's a huge ocean's gap between their interests, then the only possibility is babbling. Then this sort of spiral of exaggeration and discounting that I was talking about, it just goes out of control, right? And nothing can be believed, really. If they have different interests, if they have some conflict of interest, but not too large, then this spiraling of exaggeration and discounting, it ends, it peters out. Beyond the point, it doesn't happen. Another point to note is that useful information exchange depends on both incentives and coordination, right? You've already seen the incentive part. This bias factor cannot be too big. It cannot be greater than 1/4. That is illustrating this point, that their interests and the clash of interests that they have, that is of some relevance. What is the other point? The other point is that we have already seen two equilibria. Suppose B is less than 1/4. So you have the babbling equilibrium. You also have this two interval partition equilibrium, right? And in any game with multiple equilibria, there's a coordination problem. Which equilibrium are we going to play? And so that's the second feature that we already see, that in these kinds of cheap talk games, there may be a coordination issue, right? How much we are able to convey information to each other may depend on expectations, past practices, and so on. And finally, as I said, the equilibrium interval lengths are uneven. So if information is broken down into categories, but the categories are not equal. And so there are two sources of information loss, really, and welfare loss. One is that exact information cannot be conveyed in a credible manner, right? Information gets coarsened, that is one source. But also it gets coarsened in a skewed manner, right? The right interval is bigger than the left interval. And so that's a further source of welfare loss that we see. Okay. Now, yeah, so I will end here. So next, what I will show you, and that will come up in the video which I will post, will generalize that. So we can show that in general, the only possible equilibria are of this partitional variety, that the whole range will be split up into a number of intervals. And how many intervals we can break it up into will depend on the bias factor B, right? And I will show you how to characterize this sort of equilibrium. What values do the thresholds have to take? And then once we have understood the structure of these equilibria in these cheap talk games, we will then go on to the important question of welfare, right? And various kinds of commitment possibilities that may improve welfare of the sender and the receiver. So that will be forthcoming. Any questions?
Sir, just one clarificatory question.
Yeah.
It's that in this model, there is no way that we can possibly allow for incomplete information about the size of the bias.
No, we can. We have chosen not to. So it's always best to start simple, to introduce one or two kinds of asymmetric information and focus on that. Obviously, if you think of many kinds of applications, what you're saying would be very, very pertinent, right? I may not be, so the Prime Minister may not know whether the National Security Advisor is a hawk or a dove, right?
Yes.
And moreover, so if you allow theta to be asymmetric information as well as the bias factor to be asymmetric information, then the problem, obviously, technically speaking, becomes complicated because now it's multidimensional, right? There's a theta and a b. And what is said makes the listener draw inferences on both fronts, right? Mm-hmm. So if the National Security Advisor comes and tells the Prime Minister, oh, we need to double our defense budget, there's a crisis looming. The Prime Minister may then think, oh, maybe there is, maybe not to the extent that he's saying, but there is possibly a crisis. But he also updates his belief and he starts thinking, oh, my advisor must be quite hawkish, right? His preferences must be hawkish. We have suppressed that, okay? as we understand the known bias model, after that we can think about it and talk about it. And some of the, I have one or two references. I remember the Morgan and Stockton paper, which is in the list of papers that you guys can present, which is exactly unknown bias case. So I'll talk about it more, Arnav, and also, if you're interested in that, we can have also one-on-one. But let's postpone that for now.
Okay, sir.
Yeah. Any other questions? Okay, so just a reminder again that go and visit the course website if you haven't. Get yourself registered and bookmark it, because there'll be a steady flow of material and information there.
So there would be, there are people who didn't give me their email addresses earlier, so I'll be sending an additional list because people are still sending me emails that they haven't received the invitation.
Okay. All right. So send it to me. It's all a mess because there's no comprehensive centralized list. And I waited for the thing to settle down. So all the additional names, if you can compile it together and not in too many installments.
Sure, sir. I'll do that. The thing is, the department also hasn't taken an official preference of our subjects till now. So our subjects are also not logged.
Yeah, I know. Yeah, so if you already have a list of half a dozen or more names, just send it to me.
Sure, sir. I'll do that.
Yeah. Okay. Yeah, so I can add people at any time. So, technically there's no problem at all.
All right, sir. Noted.
Yeah. Okay, guys. See you later. So, most people have left already. Okay, I'll make the relevant announcement on the course website.